So students, this is the first question of IOQP paper part 1 2021, and my name is Vikas Agarwal. I'll be discussing the solutions with you. So let's say what the first question says. It says that there is a spherical ball of ice originally at 0 degrees Celsius, and assuming that heat is absorbed uniformly through the surface and the rate of absorption is proportional to the instantaneous surface area, which of the following option is true for the radius of the ball at any instant? Initial radius is to be considered as r naught, and the shape of ball always remains spherical. Also, L and rho are given to be latent heat and density of ice at 0 degrees Celsius. So we have to figure out the function of radius with time. So all the four options talk about the how radius changes with time. So that is what we are interested in. So let's see what we can do. So this question says that the rate of absorption is proportional to the instantaneous surface area. So at any general instant, if the ball is having a radius r, then the rate of absorption, that is dq by dt, is proportional to the surface area. So I can say that it's k times of 4 pi r square. That is what it says. It's proportional to the instantaneous surface area. Okay, now this q represents the heat that has been absorbed. This is heat absorbed by the ball. Okay, now if we are absorbing dq amount of heat, then that will lead to a reduction in the radius. Let's say the radius was r at this instant at time t. After time t plus dt, it will become r minus dr. So dr will be a negative quantity, you can say, and you can say that the radius has changed to r plus dr. Okay, so what we can say is that dq amount of heat should be equal to mod dm into the latent heat, that is dl, and mod dm can be written as rho into 4 pi r square into mod dr. So that surface area into the layer, the thickness of the layer lost, so that becomes the volume, volume into density becomes the mass, mass into specific heat, into latent heat, that becomes equal to dq. Now mod dr can be replaced by minus of dr into L. So we can substitute this value of dr here, dq here, so that will give us rho 4 pi r square minus dr into L by dt is equals to k into 4 pi r square. So 4 pi r square and 4 pi r square gets cancelled. So from here we can say that dr by dt is coming out to be minus of k by L rho. So that is what we are getting here. K represents the proportionality constant. Now if we go back and check the options, we can see that option C is the correct one. It says radius of the ball decreases with time linearly with a slope this much. So C option looks to be the correct one. I hope you understood the question, guys. See you for the next question. So this is next question, question number 2. This question says that work done by 3 moles of an ideal gas in a cyclic process ABCD shown in the diagram. Alright, so guys, the question looks to be very easy. Actually, this AB straight line, it passes through a region, and we are looking at a P versus T diagram. So this means that AB process is isochoric process. Okay, similarly BC process is a constant pressure, it's an isobaric process. CD process, again it's a straight line passing through a region, so CD process CD process suggests an isochoric process, and DA process is again an isobaric process. So we have been told to find out the work done by the gas. So out of the 4 processes that we have done, AB, BC, CD and DA, 2 processes are isochoric, which means that work done in them will be 0. So work done in A and B process will be 0, work done in C and D process will be 0. Okay, now we are left with the BC process and DA process. So work done in BC process can be written as, since BC process is an isobaric process, for an isobaric process work done can be written as P delta V, which becomes equals to NR delta T. So we can write it as NR into change in temperature, which is 600 minus 200, so that's 400. Similarly, work done in DA process, work done in DA process can be written as, again as NR delta T, because DA process is also isobaric. So we can write NR delta T. So we are going to write NR into change in temperature will be minus 200. So this, so total work done will be equal to how much? It will be equal to the sum of these 4 values. Okay, and that becomes equals to 200 into NR. We can put the value of N, we can put the value of R. So 200 into N is 3 and R is, we can assume R to be 25 by 3. So this gives us 5000 joules. which is 5 kilojoules. So B option is the correct one here. I hope you understood the question. I hope you liked it. Okay, so we are now looking at the third question. So third question says that the molar specific heat capacity has been given to us, and it has been given as Cv plus alpha P by T. Now that's the molar specific heat capacity of a gas in a certain process. We want to find out the equation of state for the process. Now the general formula for C for any process is given as Cv plus R upon 1 plus VdP by PdV. So this is the general formula of molar heat capacity for any process. If we compare the two, we realize that alpha P by T can be equated to R divided by 1 plus VdP upon PdV. This we can write. This can be written as PdV upon PdV plus VdP. We can write it like this. Now this PdV plus VdP can be further written as nRdt. How am I writing this? We know that PV is equals to nRT. So if I keep the number of moles of gas fixed, then there are three variables P, V and T. So if I differentiate this relationship, I will get PdV plus VdP is equals to nRdt. So from here we are substituting this. Now once we do this, we can say that this quantity is equal to this quantity. The P will get eliminated and we are going to get alpha by T is equals to dV upon nRdt. So this can now be written as dt by T into alpha nr. Let's keep the constant quantities together. So alpha nr into dt by T is equals to dV. So from here we are going to get alpha nr ln T is equals to V plus some constant of integration. Alright, so this would mean that I'll go to the next page. So I'll write the equation here. Alpha nr ln T is equals to V plus some constant of integration. So this would mean that ln T can be written as V plus C upon alpha nr, which would mean that e raised to power V plus C upon alpha nr is equals to T, or you can say that T is equals to some constant like into e raised to power V by alpha nr. So we will check whether we have such an equation in one of the options. If it is there, then it is going to be the answer. So T is coming out to be proportional to e raised to power V by alpha. So let's go back and so D option looks to be the correct one. Here we are getting some constant into e raised to power V by alpha. Okay, so for this question, this would be the correct answer. Now this is a standard question that is generally covered while teaching the motional EMF concept. I'll solve this question. So there is a current I flowing in this wire and there is a rod, a conducting rod of length L, which is being moved parallel to the wire such that the rod remains perpendicular to the wire as depicted in the figure. So we have to find out the EMF induced in the rod. So what we are going to do, we are going to consider an element on the rod at a distance x from the wire. The length of the element can be considered as dx. So in this dx length, some EMF will be induced that can be written as dE, and this dE will be written as the speed of the rod into the length of the element into the magnetic field at this place. Now the magnetic field at this place will be produced because of the current flowing in this wire. So we are going to write it as mu naught I by 2 pi x. That's the formula of magnetic induction due to a current carrying straight infinite wire. So that's it. To get the EMF, we just need to integrate this expression. So mu naught IV, these are all constant quantities which are not changing with on changing the element. 2 pi is also constant. So we will be left with ln x, and the limit of x changes from 2L to 3L. So it becomes mu naught IV by 2 pi into ln 3 by 2. So we should be searching for such an option, and option D matches with this one. So option D will be the correct answer for this question. Okay, this is the next question, and again it is one of the standard theory questions. You don't even need to solve this question. So it says that there are 2 point charges Q and Q, okay, and they are located at 0 comma L. So we can consider this as the origin. So this is x-axis, this is 0 comma 0, and this is L comma 0. Now the electric field strength in this region, is depicted by. So one thing that a null point will be present midway between the two charges, so the electric field at this point should be 0, which has been depicted in all 4 graphs. So based on the basis of this, we cannot reject any of the options. But in this region, the electric field of this charge will dominate, so the direction of electric field should be like this, and after this the direction of electric field will be like this, because the other charge will dominate now. So since the direction of electric field is different on either side of null point, therefore the sign of electric field must change. So we can rule out these two options, because here electric field has been depicted positive at all times. So that is definitely ruled out. Now we are left with two options, C and D. Here pay attention to the fact that when we go very near to a point charge, the electric field tend to become infinite. Option C depicts a finite value of electric field as we are approaching x equals to 0 or x equals to L, whereas option D depicts that the value of electric field is tending up to a very large value as we are approaching x equals to 0 or x equals to L. Therefore option D will be the correct one here. So straightforward question, not too difficult. You just had to eliminate the options. I hope you understood this. See you for the next question. Now looking at question number 7, it says that a simple circuit consists of unknown resistance Ra and an unknown resistance Rb, both in series with a battery of 9 volt and negligible internal resistance. When a voltmeter is connected across Ra, it measures 3 volt, but when the same voltmeter is connected across Rb, it reads 4.5. Okay, now this statement was enough to tell us that we have to consider the internal resistance of the voltmeter also, but that has been clearly mentioned that voltmeter has finite resistance. So they have made the task easier for us. Let's see how we can make the circuit. So this is let's say resistance Ra, and it is connected with another resistance Rb, and the two are connected to a 9 volt battery. The internal resistance of this battery, we have to ignore that. Okay, and then we connected a voltmeter across Ra, as a result of which the voltmeter gave a reading of 3 volt, which means that 3 volt was the potential drop across these 2 points. Okay, now the equivalent of these two, if I consider the resistance of the voltmeter as small r, then the equivalent of these two will be written as Ra into R upon Ra plus R. Okay, so this becomes the equivalent value. Now the total EMF given to us is 9 volt. If 3 volt is across this combination, then 6 volt will be across this combination. Okay, now this entire combination is in series with Rb, so it means that the potential drop will be proportional to the value of the resistance. Therefore we can claim that this value into twice should become equal to Rb. So that will become your one of the equations. Okay, here we are getting a potential drop of 3, here we are getting a potential drop of 6. That means resistance B is 2 times the equivalent value of those two. Okay, now the question tells us that instead of connecting the voltmeter across RA, if we would have connected it across RB, then the reading would have been 4.5 volts. So if I redraw the circuit by assuming that the voltmeter is connected here, then in this case the result that we get 4.5 volt drop here. So 4.5 volt will be the voltage drop across RA also, because the total EMF is 9 volt, which would mean that RA is equal to the equivalent of these two, which would be written as RB into R upon RB plus R. So this will become your second equation. On solving these equations, we'll get the values of RB also and small r also. Like, we intend to find the value of RB and small r. There are two equations, there are two unknowns. We will get the value. There is no complication involved. You just do the mathematics. I'm not doing it here because it's not worth doing it here. You can yourself do it. You can finish the calculation. This is what you're going to get the answer. So very simple question. This particular one, you can say. All right. Now this is an amazing question that came in the paper. Let's do this question. Question says that optical powers of objective and eyepiece of a compound microscope are 100 diopter and 20 diopter. Now this would mean that the focal length of objective is 1 centimeter and the focal length of eyepiece is 5 centimeters. So we have been given the focal length of objective as well as eyepiece by in the first statement. Now the microscope magnification being equal to 50 when final image is formed at least distance of distinct vision. So let's try to understand how a microscope functions. So in a microscope, the first lens is called the objective, and that lens produces a magnified image. Okay, that a real and magnified image is produced, and then this image is being used as object by the second lens, which is the eyepiece, and the eyepiece itself functions as a simple microscope. That means this object, the object for eyepiece must lie within focal length. Like, the distance of this from the eyepiece is less than the focal length of the eyepiece. Anyway, that part is not important here. And now we get the image, we get a magnified image, and right now the question says that we are getting the magnified image at a distance capital D from here, where capital D is the distance, least distance of distinct vision. Now for this case, this distance, the distance of object from the lens, for which case? For the case when V is equals to minus D, F is equals to plus FE, we can obtain the value of U. And when you do that, like when you put these values into the lens formula, you get mod U as dFE upon D plus FE. So if I put these numbers here, D is 25, FE is 5, then 25 plus 5 will become 30. So this becomes 25 by 6 centimeter. So this is the distance at which this image should be formed. So this we have got. Now in such a scenario, the magnification, the formula for magnification is mod V naught by mod U naught into 1 plus D by FE. So this will become mod V naught by mod U naught into 1 plus D by FE. So that will become 1 plus 25 by 5. So this will become mod V naught by mod U naught into 6. Now in the question, magnification was given to us as 50. So 50 is equals to mod V naught by mod U naught into 6. So from here we get mod V naught by mod U naught is equals to 25 by 3. This is what we are getting. Now I'll try to obtain the value of V naught, and how I'm going to do that? I'm going to use the lens formula for objective lens. Now for objective lens, U will be written as minus of mod U naught, V will be written as plus mod V naught, because we got a real image of a real object. F will be replaced by plus F naught. So I'm going to substitute these numbers. So we are going to write 1 upon mod V naught minus 1 upon minus mod U naught is equals to 1 upon 1. So from here, if I multiply this entire equation with V naught, then we get 1 plus mod V naught by mod U naught is equals to mod V naught. And now we can substitute this ratio from here. So 1 plus 25 by 3 is equals to mod V naught is what we are getting. So 28 by 3 is mod V naught. That means in the first scenario where we used the microscope, this distance was how much did we get? I think it was 28 by 3. Let's just check this value. So 28 by 3. So this distance was 28 by 3. Now what we intend to do, we intend to shift the objective lens by 2 centimeter, by an additional of 2 centimeter. Correspondingly we will have to shift the object somewhere so that the image can be formed at this location only. Actually this distance should be 28.3. So we would want to get the image here only so that we can continue to view in the near point setting, in the near point adjustment. So we have to get the image of objective here. We have shifted the objective, so the value of mod V naught will change. Correspondingly we'll have to change the value of mod U naught. Okay, so let's see what we are going to do. So the new value of mod V naught would be the previous value plus 2 centimeter. So that would become 34 by 3 centimeter. This is the new value of mod V naught. The new value of mod U naught is what we want to find out. Okay, and for that I'm going to use this actually it should represent U. I'm going to use lens formula again. So V will be this, U will be this, and F will be plus F objective. That means 1 centimeter. So let's put these values into the equation now. So we will have 1 upon 34 by 3, 1 upon 34 by 3 plus 1 upon mod U naught prime is equals to 1. In fact, what we can do, we are actually interested in the ratio of mod V naught prime by mod U naught prime. So let's simply multiply this entire equation by mod V naught prime. So by doing that, we'll get a 1 here, we'll get mod V naught prime by mod U naught prime is equals to mod V naught prime, which is how much? Which is 34 by 3. So this would mean that mod V naught prime upon mod U naught prime is 34 by 3 minus 1, so that's 31 by 3. Now once we have this value, we can find the new value of magnification as mod V naught prime by mod U naught prime into 1 plus d by Fe. Remember, this part remain as it is because the image formed by the objective lens is at the same distance from the eyepiece as it had been before. And why this distance need to be maintained? This distance need to be maintained so that we can continue to use the microscope in the near point setting. So this number remains as 6. So this number became 31 by 3. This number continues to be 6. So 62 would be the new value of the magnification, and I do believe that 62 was one of the options. So option A will be the correct one. So a very good question. This is one question where I believe that many of the students would have struggled. Firstly, because this topic many of the students do not prepare well, as it is not part of JEE advanced curriculum, it is part of only JEE mains curriculum. So many of the students ignore this topic, and even if they prepare this topic, then they do not go into the depth to understand this topic. They just mug up the formula, which is not a bad ploy if you are just aiming JEE mains. But now in NSC paper like IOQP paper, a very good question has been given, and this was a good question. I hope you have understood how to address this question. So this is question number 9. देखते हैं ये question क्या कह रहा है. So this question says a non-conducting cone of base radius. So एक non-conducting cone हम बना लेते हैं इस तरह की. ठीक है, इसका बेस रेडियस हमको गिवन है, दिस इज आर. इसका एंगल हमको गिवन है, दिस एंगल इज अल्फा. अल्फा इज गिवन टू बी 15 डिग्री. ठीक है. नाउ इट हैज़ अ यूनिफॉर्म सरफेस चार्ज डेंसिटी अप टू 3/4 ऑफ इट्स स्लांट लेंथ. तो इसका मतलब इसके अंदर जो चार्ज प्रेजेंट है वो यहाँ कहीं तक प्रेजेंट है, मतलब कि ये पूरा रीजन जो है ये रीजन चार्ज्ड है. ठीक है, समवॉट लाइक दिस. ठीक है, इसकी वजह से वर्टेक्स पर जो इलेक्ट्रिक फील्ड है वो हमें निकालना है. ठीक है, तो इसके लिए हम क्या करेंगे, व्हाट वी आर गोइंग टू डू, वी आर गोइंग टू कंसिडर एन एलिमेंट अलोंग द स्लांट लेंथ at a distance x from the vertex. Consider a ring shaped element of width dx. Now for this ring, my first aim would be to write the charge. So dq, charge will be written as sigma into area of the ring, which will be written as sigma into 2 pi r, where r will represent the radius of this ring, okay, into dx. Okay, now sigma into 2 pi. Now can be replaced as x sine alpha. Please check this. This length is x, so x sine alpha into dx. So this has become the charge on the element. Next, what we are going to do, we are going to write the electric field due to this ring, this elemental ring, the electric field due to this elemental ring at the vertex. So let's call it as dE. So next we are going to write dE, and dE will be written as k into charge into x. Now here in the formula for electric field due to a ring on a point at a point on the axis of the ring, the distance that we write is actually the distance from the center of the ring to the point where we are trying to find out the electric field. So this distance we have to write. So this distance will become x cos alpha. Okay, let me erase. Okay, so this distance will become x cos alpha divided by, we get root of x square plus r square raised to power 3 by 2. That means we get cube of this distance, which is right now x only. So this is the formula. Now we are going to substitute the value of dq. So it's sigma into 2 pi into sine alpha into x dx. Okay, that's dq. Now dq will be multiplied with x cos alpha. So we'll get x square here and we'll get a cos alpha here. This entire thing will be divided with x cube. So that will leave us with k sigma. So I have taken care of k, I have taken care of sigma, into pi, I have taken care of pi. 2 sine alpha cos alpha can be replaced by sine 2 alpha, and then we will be left with dx upon x. So we have taken care of everything. Now we just need to integrate this result. All the different elemental rings will produce electric field in the same direction, so we can simply integrate this result to get the electric field. So integration will give us k sigma pi sine 2 alpha. Alpha is 15 degree, so sine 2 alpha will become sine of 30 degree, which is half. So I'll simply write half here. Okay, and then we will have ln x. X is changing from L by 4 to L, where L represents the slant length, you can say. So L by 4 to L. So this will become, I can also change k to 1 upon 4 pi epsilon naught. So 1 upon 4 pi epsilon naught into sigma into pi by 2, and then we are going to get ln 4, which can also be written as 2 times of ln 2. So we are going to get pi gets cancelled, 2 gets cancelled, so sigma by 4 epsilon naught into ln 2. So this is the expression that we should be looking for. So sigma ln 2 by 4 epsilon naught, B should be the correct answer here. So question number 10. Freely falling spherical raindrop, just a minute, yes, gathers moisture from the atmosphere at a rate of this. T is in time, m is the instantaneous mass of the drop. Constant is this. Constant, the value of constant is given to us. If the drop of initial mass of 2 grams starts falling from rest, the instantaneous velocity of the drop exactly after 5 seconds shall be. Okay, so the important point to understand here, the question does not mention anything regarding the size of the drop. It only says that the drop keeps on absorbing the moisture, and hence the the mass of the drop is increasing. So at t equal to 0, a drop of mass m naught has been dropped. It keeps on falling, and at a general time t, the mass would have become different. Let's denote it by m. The question says that dm by dt is kt square. Now this would mean that dm can be written as kt square into dt, which would further mean that m minus m naught can be written as kt cube by 3, which would mean that instantaneous mass or mass at a time t can be written as m naught plus kt cube by 3. Now if this is the mass of the drop as a function of time, then we can say that the gravitational force acting on the drop is also changing as a function of time, and this force will be written as mg. So what I intend to do, I intend to calculate the impulse due to the gravitational force. Okay, so the impulse will be given by integration of f dt from 0 to the desired time. The desired time here is 5 seconds, which currently I am representing by, let's say, t naught. So 0 to t naught. So this will become integration of f dt will become m naught into g into t naught plus k t naught raised to power 4 by 12. So this is the impulse that we are going to get. Now to get the velocity at a time t naught, you simply have to divide impulse with the mass. So I'm going to do that. So it will become m naught into g plus kt naught cube by 12. I am pulling out t naught as the common quantity, and then I'm going to divide it with m naught plus k t naught cube by 3. So that's it. You just have to substitute the numbers here. We have the value of m naught, that is 2 gram. We have the value of g is not given to us. The value of g has to be substituted from our side. You can substitute 10 also, you can substitute 9.8 also. The value of k is given to us, and everything else is known to us. So the units will take care of themselves, so you don't need to worry about them. Just substitute the value here. Okay, and let me do that for you. So m naught was given to be how much? M naught was 2 gram. So 2 gram into, okay, we can do one thing. This g was actually common here, it should have been present here also. So we can pull out g as the common quantity. Okay, so I'll keep g as the common quantity, and I'll multiply it towards the end. So 2 gram plus 2 gram, and this will become plus. Instead of cross, I will write a plus. K is 12 gram per second cube into we'll have t naught cube. So t naught is 5 seconds, so that's 125 second cube upon I think it was 12 upon 12. Okay, this entire thing is to be multiplied with 5 seconds into g. Let's take it as 9.8 meter per second square. Now we are going to divide this entire thing with instantaneous mass, which is m naught 2 gram plus k t naught by cube. So 12 gram per second cube into 125 second cube by 3. So this is what we are getting. Now you can see here that this s cube gets cancelled. So this term, this entire term we are getting in grams. The denominator is also in grams. Grams gets cancelled. So here we are left with SI unit of velocity, which is meter per second. So I'll just finish the calculation now. So 2 plus 12 cancels each other. So 125 divided by 2 plus, this will become actually I think, yeah, everything is okay. So this will become 4 into 125, that's 500. So we are left with this 5 into 9.5. Okay, so this gives us 127 into 5 into 9.8 divided by 2 plus 500. So this will become equal to 12.4 meter per second, which is one of the options, I believe. So option A will be the correct one here. So next question says that two planets each of mass m and radius r are positioned at rest in space. So let's say this is a planet of radius r, and at a distance of 4r another planet is positioned, like the distance between the center is 4r and this is also of the radius r. Now we wish to fire a projectile from the surface of one planet to the other. The minimum initial speed for which so our task is to throw a projectile from here. Let the mass of the projectile be small m, and we want to throw it with minimum speed so that it can reach the other planet. Now in these questions, the most significant aspect is to keep in mind that there will be a null point. Like as we travel from the surface of one planet to the surface of another planet, there will be a point where the gravitational field will become zero. Okay. To the left of this point, the net gravitational field will be like this. That means with whatever speed we have thrown the projectile will slow down. It will keep on slowing down. And if it comes to rest before crossing the null point, then it will go back and land on the first planet itself. But if we are able to make sure that the projectile crosses this null point, it can do that even with negligible velocity. But if it is done once, then the net gravitational field in this region will be towards right, and therefore the projectile will then start accelerating. It will then start gaining speed, and it is sure to fall on second planet. So the key idea here is to ensure that the projectile reaches the null point. Even if it does that with zero velocity, then also we are happy. So considering the null point as the final point, we will write the work energy equation. And one more thing, the question had been made a little bit easier by giving us planets of equal mass, because now even without doing any calculation, we can predict that the null point will be the midpoint. So considering this as the initial location, this as the final location, I am writing the energy equation. So when the projectile was at the initial point, the potential energy or the interaction energy of the projectile with the two planets will be written as minus gmm by r. That's the interaction energy with the first planet, plus minus of gmm by 3r, because the distance of the projectile from the center of the second planet is 3r. So that's the initial interaction energy. The kinetic energy that we gave, I'm writing it here. So ui plus ki is equals to uf plus kf. So uf plus kf is what we have to write. So I'm writing it here, the right hand side, I'm writing it here. There was no space there. So uf will be written as minus gmm by 2r into twice, because both the interaction energy with both the planets will be equal now, and the kinetic energy, we are happy even if it's negligible. So from this equation, solving this equation, we can get the value of V0, and that will be our answer. So it's looks like a easy question, this one. So half m V0 square is equals to, here we are getting minus 1, and here we are going to get, like this is both these terms are going to become plus on going to the opposite side of equality. So 1 plus 1 by 3. So we are going to get 4 by 3 minus 1 into gmm by r. Okay, m gets cancelled, this becomes 1 by 3, so v0 will become root of 2 by 3 gm by r. This is merely calculation part, you can finish it on your own. B option looks to be the correct answer. I hope you have understood the question, guys. It was an easy question. So next question says that a uniform metallic rod of radius r rotates with an angular velocity omega, and we have to find the elongation. Again, this is one of the standard questions that is usually taught in many of the coaching institutes and classes, whatever you are covering. So this is a rod of length L, and this rod is undergoing rotation like this about one end. Now at a distance x, if we consider the tension to be T, how we can find this tension? We are going to write the force equation on this segment of the rod. So this segment has the length of L minus x, And if I simply pay attention to this segment and ignore the remaining of the rod, then I will say that this segment is moving in a circle like this, right? Think about it. This segment is going in a circle like this. Like this segment will acquire this position at some point of time, right? Okay, so we can also claim that the center of mass of this segment, which should be at its midpoint, this center of mass is going in a circle like this. Okay, so I'm going to use this fact. I'm going to write the force equation, Newton's second law, on this segment of the rod. So this segment of the rod has length of L minus x, and it is being acted upon by tension, and because of this tension it is going in circle. So I'm going to write T is equals to m omega square into r, but m we are going to use as the mass of this segment only, r we are going to use as the radius of the circle in which center of mass is moving. So m will be written as mass upon length into L minus x. This entire thing becomes the mass of the element into omega square into radius. So radius will be written as x plus L minus x by 2. Have a look at this. This length plus half of this length. So x plus L minus x by 2. So this will become m by L into omega square into L minus x into this is going to become L plus x by 2. So it becomes m omega square L square minus x square by 2L. So we have got tension as a function of x, and the expression I'm writing it here again. So m omega square L square minus x square by 2. Now what we are going to say that, let's say this was the rod of length L. Okay, consider a small segment of length dx. Okay, due to rotation of the rod, this segment has expanded by some amount. It is no longer of length dx, it has become dx plus dl. So dl will indicate the elongation in length dx of the rod. So dl is elongation, it's elongation in length, or in element of length, in element of length dx, which would mean that dl by dx indicates the strain. It indicates the strain, which would mean that tension by cross-sectional area is equals to Young's modulus into dl by dx, which would mean that T dx by ay is equals to dl, which would mean that T by ay, now instead of T we can write m omega square by 2 L square minus x square into dx is equals to dl. Now if I integrate both sides, dl represents elongation in one element. If I add up elongation in all elements, then I get the total elongation in the rod, and here x will change from 0 to L. So we are going to write m omega square by 2ay, m omega square by 2a. Actually I think there should have been a denominator L in the denominator also. I think I missed one L here, 2L it was. So okay, so m omega square by 2 lay, and then when we integrate we get L square x minus x cube by 3, and limits will be from 0 to L. This is delta L. So it is going to become m omega square, okay, let me write it on the next slide. So m omega square by 2 lay and then 2 lay and then L cube minus L cube by 3, okay, is equals to delta L. So it will become m omega square by 2 lay into 3L square minus L square is 2L cube by 3. Okay, and now we have to give the answer in terms of rho. Okay, so mass can be written as density into cross-sectional area into length of the rod into omega square. This 2 gets cancelled. In fact, one of the L also gets cancelled. So by 3ay. So now A also gets cancelled. Sorry, A gets cancelled, not Y. So rho omega square L cube by 3y is delta L. Let's see whether we have an option like this. So rho omega square L cube by 3y. B option looks to be the correct one. Let me check. Rho omega square L cube by 3y. Rho omega square L cube by 3y. Yeah, so B option looks to be the correct one. So guys, I hope you have understood the solution here. Now this question generally is covered by teachers when they teach elasticity. So I'm expecting that many of the students would have been able to do this question. But if the students are not exposed to this question a priori, then it is unlikely that the student will be able to solve this question. So I hope the solution was clear to you, and next time when you come across such a question, you should be able to solve this. Okay, next question is something for which you don't even have to move your pen. You can observe and answer. Let me tell you how. So it is given that the particle has a total energy E and it is moving in a potential field. The potential function is plotted against X. Okay. Now let's try to understand this, that the total energy is E. Now total energy is sum of kinetic energy plus potential energy. So wherever potential energy is going to become equal to E, kinetic energy is going to become 0. So in this region we can see that the potential energy is E, the potential energy is E in this region. So in these two regions kinetic energy cannot be present, which means momentum cannot be present. So any graph of momentum versus position, like the graph that we are trying to make, we should mark a 0 and a 0 for these positions at least. So all graphs are like that only except this one. This one shows non-zero values for large values of X also. So this one is definitely ruled out. Okay. Next, what it shows that the potential energy dropped from E to a certain value, which would mean that the kinetic energy increased from 0 to a certain value, then potential energy increased again. So it would mean that the kinetic energy dropped again, but potential energy did not become equal to E. So kinetic energy did not become equal to 0, and then potential energy dropped again, and it dropped to a greater depth as compared to previous value. So the kinetic energy will rise to a greater height as compared to the previous value, and then it will become 0. So this is the graph of kinetic energy. And as far as the qualitative nature is concerned, like if we are seeing two peaks in the value of kinetic energy, then we should be seeing two peaks in the graph of momentum also. And even those, the height of those two peaks, for example, here the first peak is the shorter one, the second peak is the longer one. The same thing should happen in the graph of momentum also. Based on these observations, we can rule out this. Here the two peaks are shown to be of equal height. Here the first peak is shown to be of higher height, so this is ruled out. So option A should be the correct one. So A will be the correct graph here. So next question says that there is a hollow metallic cylinder. So there is a hollow metallic cylinder. The radius is given to us, and it is carrying current of 2 ampere parallel to its axis, distributed uniformly over the entire circumference. So the current is flowing on the surface of this cylinder like this. Okay. So because of this current, there will be some magnetic field at the center, and this magnetic field can be written by using the expression for magnetic field due to an infinite wire. So mu naught I by 2 pi r will become the magnetic field. Now the pressure due to this magnetic field, the formula for that is b square by 2 mu naught, and this is what we were supposed to do. Finishing this calculation will give us the result. So 1 upon 2 mu naught into mu naught square I square by 4 pi square r square. So we can cancel one mu naught, and that's all. So I square into mu naught, okay, divided by 8 pi square r square will give you the answer. Mu naught can be written as 4 pi into 10 raised to power minus 7. I square will become 4 because I is 2, divided by 8 pi square can be written as 8 pi into pi, and then we have r square. R is 0.5, so 0.5 square will become 25 upon 100. Yes. Okay, now we can finish the calculation. So 4 pi can be cancelled with this and 2 will be left here. So we are getting, this will become 4. So 8 by pi into 10 raised to power minus 7. And the closest value would be like 8 by pi. So the closest value seems to be this, because in other option even the power of 10 are varying significantly. So D option looks to be the closest one. You can finish the calculation and confirm. So next question says that there are two masses that move on a collision path. Before collision, the object of mass 2m. So this object was moving with a speed v. Okay, and this theta angle is given to be sine inverse of 3 by 5, which is very close to 37 degree. Okay, so let's assume it to be 37 degree, and then another mass of another object of mass m is moving with a speed of 3v by 2, and this angle is going to be sine inverse of 4 by 5, which is again close to 53 degrees. So the initial motion of these two particles was perpendicular to each other, like the line of motion was perpendicular to each other. After collision, the object of mass 2m is observed to be moving right with a speed. So this is moving rightwards with a speed of 4 by 5v, and there are no external agents. So guys, to do this question, let's calculate the components of momentum of these particles. So the momentum would be in this direction, and it would be 2mv. That would be the momentum. So the horizontal component would be 2mv cos 37. So that would become 2mv into 4 by 5. So that's 8 by 5 mv. And the vertical component would be 2 mv into sine sine 37, 3 by 5. So 2 mv into 3 by 5. Alright, similarly for the other particle, the momentum vector would be 3 mv by 2. But when we try to find out the vertical component of it, we will get 3 mv by 2 into sine phi. Sine phi will be how much? It will be 4 by 5. Okay, and the horizontal component will be in this direction, and its value would be, I'll write it here, 3 mv by 2 into cos phi. Cos phi would be 3 by 5. So here we are getting 6 mv by 5. Here we are getting again 6 mv by 5. So these two gets cancelled. That means overall the system did not have any momentum in the y direction. It only had momentum in the x direction. So velocity of center of mass after collision is 0. That is certainly not true, because we did have momentum in the x direction. So velocity of center of mass is not going to be 0. Whatever it was before the collision, it is going to remain the same, and it depends on the total momentum of the system, which is non-zero. Therefore it is, A option is incorrect. Center of mass is moving along x-axis before the collision. Center of mass is moving along the x-axis before the collision. Okay, this statement seems to be true. Let's check the other statements also. The velocity of the center of mass after collision is this much. So velocity of center of mass after collision can be obtained by total horizontal momentum, or total momentum in the x direction, divided by the total mass. So this value is 8 by 5, and this value is 9 by 10. So 8 by 5 plus 9 by 10. Other things are like, that's just mv. So it will become 16 plus 9, 25. 25 by 10. So that's 5 by 2 mv. So that's the momentum. Okay, so 5 mv by 2. Now we'll have to divide it with the total mass, which is 3m. So m gets cancelled. So we get 5v by 6. So that's the velocity of center of mass. So this option is incorrect. A was incorrect. Now option D. Total linear momentum of the system before the collision is 5 by 6 mv. You have already figured out what was the total linear momentum. Again, it is different than this value. So this is incorrect. So yes, only option B is the correct one. So this question says that a large hemispherical water tank of radius r is filled with water initially up to a radius. So basically there is a hemispherical tank like this, and this tank has been half filled, or has been filled to half of its height. So this length is r by 2 and this is also r by 2. So water was filled up to this height. And then there was a small hole at the orifice through which water started coming out. The area of this hole is given to be small a, and we want to calculate the time taken by the tank to get empty completely. So let's consider a general instant of time. Like this is the tank, and let's say the water level is y right now, okay, which is less than the initial value. So right now liquid will come out with the speed of root 2 gy. That's the velocity of efflux. That we can use that as a standard formula. So the volume flow rate will be given by the velocity of efflux multiplied with the cross section area of the hole, So this is the volume flow rate. Now as a result of this volume flow rate, or in the next dt time, we can say the level change is, let's say, dy. So dy is the level change. So the volume that goes out in next dt time will be written as, if this radius is a small r, so that volume will be written as pi r square into dy. So this is the volume that goes out in the time dt, in the next dt seconds. So volume, so this becomes volume flow rate. One thing to keep in mind here, that y is decreasing with passage of time. So dy itself should be a negative quantity. So we'll put one minus sign here to make this entire term as a positive quantity. So now this represents the volume flow rate, and we can write this as root 2 gy into a. So there's one more thing to be done here. R is also varying. So to find out the value of r, we can use some geometry. For example, this distance will be equal to the radius of the hemisphere, and this distance will become equal to r minus y. So I'm going to apply Pythagoras theorem in this triangle. When we do so, we get r minus y square plus r square is equal to capital R square. So this becomes r square plus y square minus 2yr plus r square is equals to capital R square. Capital R square gets cancelled. So from here we get r square as 2yr minus y square. Let's go back and check whether it's correct or not. So 2yr minus y square, that's the value of r square. Now we are going to substitute this in the expression. So we wrote minus pi small r square. Small r square will be replaced by this expression. So minus into dy is equals to root 2g into a into root y into dt. This is I have written it in this manner. So I guess we should collect all the constants on one side of equality. So it's pi, so minus pi I have written, and then upon root 2g we can collect. So we have done that. 1 upon a, that we have taken care. And then when we bring this root y to the other side, it becomes 2ry raised to power half minus y raised to power 3 by 2 into dy is equals to dt. Now we simply need to integrate the result. From here on, even you can finish the question by yourself. I am just doing it for the sake of completion. So minus pi by root 2g into 1 upon a, and then 2r y raised to power half. Integral of this will become y raised to power 3 by 2 divided by 3 by 2 minus y raised to power 5 by 2 divided by 5 by 2, and the limit of y will change from r by 2 to 0, and time will change from 0 to t. So the integral will become t. So this is what we want to calculate. I will adjust this minus sign by interchanging the limits. So we get pi by root 2g into 1 upon a, and then I'm interchanging the limits. So this will become 4 by 3. This will become 4 by 3. I'll just cut it. 4 by 3 r. 4 by 3 r. Then r by 2 raised to power 3 by 2 minus 2 by 5 r by 2 raised to power 5 by 2. So this calculation we have to finish. So we can bring okay, pi by root 2g into 1 upon a, and then r raised to power 5 by 2 is something that we can pull out as the common quantity. So r raised to power 5 by 2, and we will be left with 4 upon 3 into 2 root 2. 4 upon 3 into 2 root 2 minus 2 upon 5 into 2 raised to power 5 by 2 will become 4 root 2. So now I think it's easy, you can finish the calculation, or okay, let me do that. So pi by root 2g into 1 upon a into r raised to power 5 by 2 into now this will become 2. So 2 root 2 can be pulled out. 2 root 2 can be pulled out. 2 root 2, we have pulled it out. So this is gone and this is gone. So we are now left with 4 by 3 minus 1 by 5. So 4 by 3 minus 1 by 5 is equals to t. This would mean pi by root 2g into 1 upon a into r raised to power 5 by 2 root 3 into, this will become 15. 20 minus 3 will become 17. 20 minus 3, yeah. So we should be looking for an expression like this. Okay, we can further simplify it a bit. So this 17 will remain as it is now. This 17, not changing this. 17, and then this root 2 and this root 2 will become 2. So we'll have 4 into 15, so that's 60. So we have taken care of this. Okay, into pi by root g into a. So this and this we have covered, and I think we also took into account this too. So this r raised to power 5 by 2 is the time. So let's see whether we have an option like this or not. So 17 by 60, yes, this option matches with what we have got. So option C will be the correct one. So this is an easy question, relatively easy question. It says that Pascal, volt, Pascal, volt and meter, these are to be taken as fundamental units, and we have to express permittivity in terms of these. So basically we have to find out the relationship between epsilon naught with Pascal, volt and length. Now if you remember, the expression for electrostatic pressure is half epsilon naught E square. If you can recall this expression, if you begin from here, the question becomes very easy, because now we can say that epsilon naught, or dimension of epsilon, or let me just rearrange this first. So 2 times of pressure by E square is epsilon naught, and E can be written as voltage, that means potential difference, upon length square is epsilon naught. So from here we get epsilon naught as 2 times the pressure into length square by voltage square. So now from this expression it is pretty easy to identify the dimension of epsilon naught in terms of pressure, voltage and length. We can see that option B fits this formula, so option B is the correct one. So this question says a cycle of wheel of mass m and radius r is fitted with a siren at a point on its circumference. So there is a wheel and there is a siren on this wheel, okay, and it is mounted on a horizontal axis about 3 feet from the ground. An observer stands in the vertical plane. So an observer stands somewhere here 100 meter away from the axle. So this distance is given to be 100 meter. Okay, this distance is given to be 100 meter. Now the radius of the wheel has not been explicitly given in this question, but the question says that axle is about 3 feet above the ground. So we can assume that the radius is about 3 feet, okay, which is like less than a meter, like 3 feet. 1 feet is about 30 centimeter, close to that. So 3 feet would be about something close to 91 centimeter. So it is like less than 1 meter. So this radius is less than 1 meter and the distance is 100 meter. Now the question says that the siren emits a sound of frequency 1000 hertz. The wheel rotates clockwise. So the wheel is rotating like this. with a uniform angular speed which is given to us. So omega is given to us as pi radian per second. At t equal to 0, siren is nearest to the observer and moves downward. So siren is here, it is moving downward. Now the observer records the highest pitch for the first time, after which time. So highest pitch will be recorded when this siren moves directly towards the observer. So at whichever point you are considering the observer, let's say the observer, the size of the observer is not given, so let's just consider any point here. So if I draw a tangent from this point on the circle, so when this siren reaches this point, at that instant whatever wave is emitted, that wave will take some time to reach the observer, and that will be our answer. Like we have to calculate two times, like our answer will comprise of two parts, t1 and t2. t1 will be the time taken by the siren to reach this position, and t2 will be the time taken by the wave generated at this position to reach the observer. Now since radius is pretty small as compared to this distance, so to emphasize, if I draw a small circle and then if I take a point which is very distant away, and if I draw a tangent from that point to the circle, that tangent will basically become a tangent to the highest and the lowest point of the circle. So this siren must travel 3/4 of a circle. So t1 will be given by 3 pi by 2 divided by omega, and then the distance along this tangent or the horizontal distance can be considered to be equal. So 100 meter divided by the speed of sound, which is 330. So this will give you the result. So if I consider omega equal to pi, this will become 1.5, and 100 by 330 is close to 0.3. So it is going to become 1.8 seconds. So B option will be the correct answer. Okay, now this is an interesting question. Let's see how to do this question. It says that there is a right angled transparent triangular prism. So let's just make a right angled prism like this. Okay, and ray of light is incident on face AB parallel to hypotenuse BC. So let's consider this as the hypotenuse. So a ray of light was incident on this prism, somewhat like this, parallel to the hypotenuse BC. So if this angle is theta, then the angle of incidence will become 90 minus theta here, and the ray, instead of going straight, will bend towards the normal. This will become the angle of refraction, and it will strike AC at some point. I will draw another normal here. Now the question says that if it emerges along AC like this, it goes, which obviously means that this angle is going to be the critical angle. Okay, this angle is the critical angle. So that is situation one. Now in another case, for the same prism, we are now sending light from the other side. Again, this is B, this is C, this is A, but this time we are sending light from this side like this. Just a minute, I did not draw it straight. I'll erase this, and yeah, so again it's not straight, but I think we should just work with it. So again we will draw the normal here. This time this angle will be 90 minus theta, so this will be 90 minus theta, so this will be theta. It will again bend towards the normal, and this time the question says that it suffers TIR. Okay, it suffers TIR, which means that this angle is larger than the critical angle, whatever that angle is. So let's first try to write this angle in terms of theta. So or let's call this as R dash. Okay, so this angle is 90 degree, this angle is 90 degree, and if I just extend the incident rays here, then this angle is theta minus R dash. This angle is theta minus R dash, and in fact this entire angle, this angle is 90 minus theta. So 90 minus theta plus theta minus R dash. So basically this angle will become R dash, and this will become 90 minus R dash. Okay, so that is the, and similarly here also Here also we can say this angle is 90 minus r, and so this angle will become r and this angle will become 90 minus r. So on both the occasions, the angle of incidence at the other interface or at the other edge surface, it will be 90 minus the angle of refraction at the first one. Now this is the scenario. So what are the conditions that we can write based on this? One, we should write Snell's law at this point, so I will write that. So sine of 90 minus theta will become cos theta upon sine of r is equals to mu. So let's call this as equation number 1. Okay, then when we write Snell's law at this point, then we are going to write sine of IC, that means cos r by sine 90, that is 1, is equals to 1 upon mu. So this will become our second equation. Again, I will write Snell's law at this point. Snell's law at this point will give us sine theta by sine r dash is equals to mu. Let's call this as equation number 3, and here we are going to write that 90 minus r dash should be greater than the critical angle. That means sine of 90 minus r dash should be greater than sine of critical angle, which means cos of r dash should be greater than 1 upon mu. So this becomes the fourth equation, or inequality you can say. So we have to work with these 4 equations to get the desired result. So let's see how we are going to use these equations. So the first step will be to eliminate r from these 2 equations. So let's do that. So sine r will be written as cos theta by mu. I'm writing it here, cos theta by mu. So sine square r plus, I intend to add cos square r to this. So going back, cos r is 1 upon mu. So 1 upon mu square is equals to 1. So this equation becomes cos square theta plus 1 is equals to mu square. Let's call this as equation number 5. So this equation we have obtained. Here we have obtained the relationship between theta and mu. Now coming back to equation number 3 and 4, I'm going to use this inequality. I'm going to find cos r prime in terms of sine r prime. So sine r prime is sine theta by mu. Okay, so from fourth equation, cos r prime will be written as 1 minus sine square r dash. This must be greater than 1 by mu. Now we are going to substitute the value of sine r prime from equation number 3. So it will become root of 1 minus sine square theta by mu square. Let's check this. Sine square theta by mu square, that's correct. Should be greater than 1 upon mu. Now what we are going to do, we are going to put the value of sine square theta from this equation, from equation number 5. So root of 1 minus 1 upon mu square sine square theta. Sine square theta is 1 minus cos square theta, and cos square theta is mu square minus 1. Okay, so this entire thing should be greater than 1 upon mu. So from here we are getting root of, I'm multiplying the entire equation by mu, so it becomes mu square minus, and then here we will have this mu square will get cancelled. 1 plus 1 will become 2 minus mu square is greater than mu. Now we can square on both the sides, so we will get 2 mu square minus 2 is greater than mu square. A slight correction here, after multiplying with mu, this entire equation we multiplied with mu, so that will leave 1 here and not mu, so it will be 1. So from here we will get 2 mu square greater than 3, which means that mu square should be greater than 3 by 2. So mu should be greater than root 3 by 2. Now based on this, I think we can answer the question. So here we see only one option which says mu should be greater than root 3 by 2. However, this option says something else also. Let's see whether we can figure this out or not. This is actually the easy part. So cos square theta plus 1 equal to mu square, we obtained that. From here we can proceed. Cos square theta will always be less than or equal to 1. Cos square theta will always be less than or equal to 1. So it means that mu square cannot cross the value of 2. That means this equation means that mu square will be less than or equal to 2. Okay, so mu has to be less than root 2. So from here we are obtaining that option B is the correct one. So we will now have a look at the next question. This question says that a circular disc of radius r, which is 10 centimeters, so this is rolling with a velocity of 4 meter per second. The center of mass without slipping, it says. Alright, so the situation is this. There is a point A which lies on the circumference, and there is the point B which lies here, which lies midway between the center and point A. And we want to know after how much time A will have the same speed as B has right now. Like, so this is t equal to 0. So if this center is going with the velocity v, this point would be going with the velocity of 2v, and B would be going with the velocity of 3v by 2. Okay. After some time, the location of center may have changed, and point A may have come here. That means the disc or the wheel may have undergone a rotation of angle theta. So at this point of time, A will have two kinds of velocity. One, a velocity tangential to the circumference, which is due to the rotation, and one due to the translation. And the velocity, these two velocity vectors will have an angle theta between them. So the resultant speed of A would be v cos theta by 2 into 2. So this would be 2v cos theta by 2, and we want this speed to be equal to 3v by 2. This means that we want cos theta by 2 to have a value of 3 by 4. From here it is pretty easy to identify the value of theta. Theta would be 2 times of cos inverse of 3 by 4, and to get the time after which this situation will occur, theta will have to be divided with omega. Omega is v by r, so it will become theta r by v. Now all the numbers are given to us, like radius is given to us, speed is given to us, theta is obtained. So we can now figure out, when we finish the calculation, we get 0.036 as the answer. So for this question, B option will be the correct one. Now this question number 21 is actually a modification of a very common question that we do. This is a common question in which one of the charged particles is kept fixed and another one is projected towards the fixed charge particle with some impact parameter, and then we try to find out the distance of closest approach between the two particles. But here the difference is that we are not assuming that Coulomb's law is applicable here, rather we are assuming a different force, a hypothetical force, and based on that we have to calculate the least distance. So the process will remain same. So what do I mean by that? So I'm again going to make use of conservation of angular momentum and conservation of energy. These are the two concepts that are used in this particular type of situation, and the justification for that, I'll also give the justification for that. As the particle travels, the particle experiences a force which always acts along the line joining the particles. Okay, so because of this, there is no torque about the fixed particle, and therefore the angular momentum remains conserved about the fixed particle. So therefore we can use conservation of angular momentum, and conservation of energy that we can use because there are no external agents which are doing work. So ui plus ki will be equal to uf plus kf. So what we need to do here, we first need to formulate a potential energy function. So f is given to us as k by r cube. So I'll start by writing du as minus f dot dr. It will transform to minus k by r cube into dr, and if I integrate this, I get u minus u naught is equals to minus k, and then r raised to power minus 3. Integration of that will become r raised to power minus 2 divided by minus 2. So it will become k by r square. 2 will also be there. So this becomes the potential energy function. Okay, now what we can do, like we can express the potential energy function as k by 2r square plus u naught. Okay, so when the particle started from here, r was infinite, so u initial is u naught, k initial is half mu square, like initial kinetic energy. This will be equal to, So when the particle is somewhere here, like the line joining the particle with the center makes 90 degree with the trajectory, at that instant we will say that the distance is least. Let's call this distance as d. So we will now write the energy at this point. So the kinetic energy at that point will be written as half mv square, and the potential energy will be written as k by 2d square plus u naught. So u naught gets cancelled, and the remaining thing can be called as equation number 1. It is based on the principle of energy conservation. Now we are going to write an equation on the basis of conservation of angular momentum. So at the initial instant, velocity vector was in this direction, so the line of motion was this at the initial instant. So the angular momentum about the center of the fixed particle would be mub, and at the final instant this angular momentum will become mvd. So m gets cancelled, so this becomes our equation number 2. That's it. We simply have to solve these two equations. We'll get the result. I'll do that solving. So half mu square is equals to half m v square. Now v can be written as ub by d square plus k by 2r square. Or sorry, instead of r we could have written d here, because we are talking about a specific point, and d is what we are trying to find out. So next what we can do, we can pull out half mu square as the common quantity. So 1 minus b square by d square. Actually no, we are trying to find out the value of d. So it will become half mu square is equals to half mu square b square plus k by 2, this entire thing into 1 by d square. We can cancel the halves as they are present in all the terms. So from here we can get d as root of mu square b square plus k divided by mu square, or you can say root of b square plus k by mu square. Now we have to substitute some values. So question says that k is equals to b square and mass is given to be 10 raised to the minus 10. V is also given. So m v naught square product will become 1. So this product is 1. So we are left with b square plus b square. That means it's root 2 times of b. So B option will be the answer. So in this question, specific activity of C14 is given in an ancient wooden toy, and it is 3 by 5 times of a recently fallen tree. So the assumption is that when that wooden toy was made or when the tree was cut to make the wooden toy, at that time the tree had the same activity as this recently fallen tree has today. So in that wooden toy, the concentration of C14 will fall with passage of time. So we are going to rely on that to estimate the age of the wooden toy. So activity of a sample is written as initial activity into e raised to power minus lambda t, and we can also write this initial activity as lambda into n naught e raised to power minus lambda t. Now this n naught can be written as n naught represents the total number of atoms that we had initially. So we can also find it as number of moles that we had initially into Na. Okay, and number of moles can be written as mass upon molar mass. Why am I doing all these things? So that we can talk about specific activity. So specific activity is activity upon mass. That's specific activity upon initial mass actually. So this is initial mass. So this will become lambda Na by m into e raised to power minus lambda t. Now notice that all of these things are constant values for a given species. Molar mass, Avogadro's number, the decay constant, these are all constant. So I can write this as c e raised to power minus lambda t, where c represents this entire thing. So specific activity today will be written as c e raised to power minus lambda t, and this is 3 by 5 times of a freshly cut sample. So this is 3 by 5 times of c, because if I put t equal to 0, I get the specific activity as c. So from here we get e raised to power minus lambda t as 3 by 5, and that's it. Once you have arrived at this equation, it's merely solving now. So if I take log on both sides, we end up getting lambda t is equals to ln 3 by, so it will become ln 5 by 3. I've adjusted the minus sign also, minus lambda t, so ln 5 by 3. So this t will be given, will be ln 5 by 3 upon lambda. Now, is the value of lambda given to us? Actually, half-life is given to us. From half-life, we can estimate the value of lambda. Half-life is what? It is ln 2 by lambda. So lambda can be written as, or 1 by lambda can be written as t half upon ln 2 into ln 5 by 3. This entire thing becomes 1 by lambda. So putting the values here, we are going to get the answer. T half is given to us as 5570. ln 2 is close to 0.7. Then ln 5 by 3, that we have to substitute by checking from the tables. Once we do that, the answer that we are going to get will be option B, like ln 5 by 3. So once we substitute the values, we are going to get option B as the answer, which is 4105 years. So now this is an assertion reason. Let's read the statement and answer. So statement 1 says that work done in bringing a charge q from infinity to the center of a uniformly charged non-conducting solid sphere. So we have a non-conducting solid sphere and we are bringing a charge from infinity, and we are claiming that the work done will be 0. Well, that certainly it's going to be false, because potential at center is 3 by 2 kq by r for a uniformly charged non-conducting solid sphere. This is the formula for potential at center. At infinity, we have 0 potential, so the work done will be equal to q times this value. So this is certainly wrong, and you don't even need to read the second statement. You can straight away select D as the answer, because it is only in option D that statement 1 is given to be false. In all other options, statement 1 is given to be true, so D will be the answer. For the sake of completion, let's read statement 2 also. Statement 2 says that the potential difference between the center and the surface of a uniformly charged non-conducting solid sphere is this much. So the potential at the surface is kq by r, and when we take the difference of these two, we end up getting this value. So yeah, statement 2 is correct. It had to be the correct, because otherwise the question would have become ambiguous. Okay, question number 24. Again, assertion reason. Current flowing in a PN junction is more in forward bias than in reverse bias. So guys, those of you who are familiar with PN junction, you would remember this as a standard result, that the current in forward bias is much more than the current that we get in the reverse bias. This is evident from the IV characteristic also that we draw. Like we draw current along with the applied voltage, and we get a graph like this. And in the reverse bias scale, this scale goes in microamperes, whereas this scale works in milliamperes. So yes, the current that flows in reverse bias is pretty small. Now the reason for that is because the diffusion current is dominant in forward bias, and diffusion current is more as compared to the drift current. So therefore, so yeah, the statement 2 is also a correct one. So the correct answer for this one would be option A, the option that says that statement 2 is the correct explanation of statement 1. Okay, now we are starting the part 2 of this paper, which basically means that we are now looking at MCQ questions. So multiple options from these can be correct. Like question number 25 till question number 32, they were all multiple options correct type. So let's see. It says that simple pendulum consisting of a mass bob of mass m attached to a massless inextensible string of length L is oscillating in vertical plane with an angular amplitude of theta. Okay, so there is an pendulum. There is a pendulum which is oscillating like this. This angle is theta m. Now in this journey, we know that the minimum tension will happen here. This will be the minimum tension, and the maximum tension will happen here. So let's try to write their values, because we have been given some relationship between these two. So minimum tension will be equal to the component of gravity in this direction. So this angle will be theta m, so this is mg, so it's going to be mg cos theta m. At this position, there is no velocity, so there is no radial acceleration, so the forces in the radial direction will balance each other. So we can say it is mg into cos of theta m. So that's question number 1. Now at the bottommost point, there is some speed, and this speed can be written as root 2g h, where h represents what? H represents the change in height. as pendulum swings from extreme position to the mean position, and that will be given by 2gl 1 minus cos theta, like h will be equal to l into 1 minus cos theta. So Tmax will be equal to mg plus mv square by r is l, and v square is 2gl 1 minus cos theta. So from here we can cancel l, and this will give us mg plus 2mg, so that's 3mg minus 2mg cos of theta m. This is also theta m actually. So this is Tmax, this is Tmin. We have been given that Tmax is 3 times Tmin. So we are going to write 3mg minus 2mg cos of theta m is equals to 3 times of mg cos of theta m. So from here we will get that cos theta m is equals to 3 by 5. You can see we are going to get this value. So this implies that theta m is close to 53 degree, because cos 53 is close to 3 by 5. So let's check the options now. We'll have to read each of the option and we'll have to figure out which one is the correct one. So maximum tension in the string is this. So 3mg minus 2mg cos theta m. So this one is the correct one. Maximum tension in the string is this. Now we can substitute the value of cos theta m and we can check, like if I substitute it here, so Tmax will be mg into 3 minus 2 times of cos theta came out to be 3 by 5. So this will become 15 minus 6, 9 by 5 mg. So even this option is correct. Maximum velocity of the bob on its way is this much. Again we have to put values here. So Vmax will be equal to root 2 into g into L is given to be 2, into 1 minus cos theta. So 1 minus 3 by 5 will become 2 by 5. So when you calculate this number, this 9.88 can be considered very close to 10. So 10 by 5 will be close to 2. So we get a value which is close to 4. Alright, so yeah, this looks like a good approximation, 3.96. I approximated 9.8 as 10, therefore the slight difference that we are getting. And the angular amplitude lies within the range. Now this is 45 degree, this is 60 degree. We obtained theta m as 53 degree. So yes, it does lie in the given range. So all 4 options are correct. So in question number 25, all 4 options are correct. Okay, so we are now looking at question number 26. It says 2 small masses lie on a large horizontal frictionless circular track of radius r. The 2 masses are free to slide on the track but constrained to move along the circle. Initially, 2 masses are tied by a thread with a compressed spring between them. Spring of negligible length being attached with none of the 2 masses. The compressed spring stores the potential. So we can say that this is a ring here and we have 2 beads here. So 2 beads, one of mass small m and the other of mass capital M, but capital M is given to be equal to 2m. So let's consider it like this, and they have a very tiny spring between them which is compressed. Okay, and it is held compressed by a thread. If we burn the thread, then the spring will release its energy. So this particle will acquire some speed in this direction, this particle will acquire some speed in this direction. So we know that this entire process, the compressed spring releasing all of its energy, in this process the momentum is going to remain conserved. So if this particle moves with a speed v, then it must move with a speed 2v. Alright, now this also means that by the time this particle, the heavier one, has covered some distance, the lighter one would have covered twice of that distance. That means we can divide the circle in 3 equal parts like this. Okay, in 3 equal parts, each making an angle of 120 degree like this. Okay, so by the time the heavier one covers one segment, okay, like by the time it travels from this position to this position, this particle will cover this entire portion because it is moving with twice the speed, so it will cover twice the distance, and they are going to collide here. This one is coming with speed 2v, this one is coming with speed v, and after collision their speeds, like here we'll have to see that what happens after collision. So we'll see to that part. So let's see how many options we can answer by whatever discussion we have done till now. So the angle turned by mass m before collision is, so the angle turned by mass m is 240 degrees, and 240 is 4 times of pi by 3. So A option is correct. The velocity of mass m on the track is this much. Now what we can say that this energy of spring is divided into the two particles, so we can write the energy equation. So u naught can be written as half m into 2v square plus half 2m into v square. So if I pull out half mv square as the common quantity from both the terms, here we will get 4 and here we will get 2. So 6 by 2, so that's 3 mv square. So v is u naught by 3m and root of this. So the question says velocity of mass m on the track. So velocity of mass m on the track was twice this value. So that becomes 4 u naught by 3m. Let's check this. Yeah. So this option is also correct. Time taken to collide for the first time is, so time taken to collide for the first time is the time taken by mass m to travel this angle, or you can say travel this distance, multiply this with r, so travel this distance with this much speed. So what I'm going to do, time will be given by 4 pi by 3 into r divided by root of 4 mu naught by 3m. So this will become, like, we can pull out this 4 as 2 and then it will cancel out. So we will be left with 2 pi r by 3 and then root of 3m by mu naught. I guess everything has been taken care of. This can also be written as 2 pi r by root m by 3 mu naught, like this. We can write it like this also. Let's check the option. So 2 pi r m by 3 mu naught. So yeah, even this option is the correct one. Now time taken for second collision. Now to calculate the time taken for second collision, we have to figure out the speeds that these particles will have after the first collision. Let's do that first. So a simple way to judge is that whatever happened here, like after collision, they should still have the velocity of separation as 3v, and the energy distribution should still be the same. So directly we can judge that this particle will start going back with a velocity of 2v, this will start going back with a velocity of v, and therefore the next collision will take place at this location again. So this will travel 2 times the distance. So next collision will happen here, and it will happen after an equal interval of time. So the value of t2 should simply be the double of this value, which we do not see. So D option will be incorrect. So A, B, C are going to be the correct options. Okay, so we are now going to discuss question number 25, and in this question the equation of an electromagnetic wave is given to us. So step one that we should do, we should modify this equation to suit our needs. So 3j cap plus bk cap, this into 10 raised to power minus 3 into sine of 10 raised to power 7, and then this thing I actually, now here what I'm getting is that the coordinate system that have been given to us, in this coordinate system the wave is propagating in x direction also, y direction also, and z direction also. So we should try to write this thing in a format where we can depict the direction of propagation of waves. So this can be written as I cap plus 2j cap plus 3k cap divided by magnitude of this vector, which is 9 plus 4, which is root 14. Okay, which is root 14 into r vector, where r is xi cap plus yj cap plus zk cap into root 14. So this entire thing I have modified and written like this. Okay, so this minus beta t is what have been given to us. So in this equation what we have made clear is that the wave is propagating in this direction, in the direction of this unit vector. Okay, and now the wave speed can be written as coefficient of t divided by the coefficient of this direction, the unit vector. So the coefficient of unit vector, this becomes root 14. So we are going to write beta as root 14, beta by root 14 equal to c. So from here we obtain the value of beta as root 14 times of c. So that makes option A correct. Now to calculate the value of B, we are going to rely on the fact that for an electromagnetic wave, electric field is perpendicular to direction of wave propagation. Now this is the direction of wave propagation. This is the electric field at a certain instant. Dot product of these two should be 0. So this will give us 6 plus 3b. 6 plus 3b equal to 0, which means b should be equal to minus 2. So because minus is not present here, therefore B option is incorrect. Okay. Next is the energy density. Now, how do we calculate the energy density of an electromagnetic wave? The energy density can be calculated by using half epsilon naught E square. So this represents the energy density, and here E represents the peak value of the current of the electric field. So this we have to calculate the average energy density. So we are going to finish this calculation. So half into epsilon naught. The expression given is in terms of epsilon naught, so we will just use E square. E is how much? So B was found to be minus 2, so the magnitude of this will become 9 plus 4, 13, root 13. So root 13 into 10 raised to power minus 3 into 10 raised to power minus 3 and square of this. So we are going to get half into epsilon naught into 13 into 10 raised to power minus 6. So this is going to be 6.5 into 10 raised to power minus 6 into epsilon naught into SI units. So yes, C option does look to be correct. And magnitude of the amplitude of magnetic field. So magnetic amplitude of magnetic field can be obtained as amplitude of electric field divided by C. So that will become root 13 into 10 raised to power minus 3 divided by 3 into 10 raised to power 8. So this will become root 13 by 3 into 10 raised to power minus 11 Tesla. So the power certainly matches, and root 13 would be close to 3.6. So 3.6 by 3 into 10 raised to power minus 11. So yes, even D option matches. So the correct answer to this question would be A, C and D. Okay, so we are now looking at question number 28, and I think this is the best question of this paper. Personally, that I liked. Very good question. Let's see how to address this question. So in this question, there is a parallel beam which strikes a semicircular, a flat diametric plane of transparent semicircular thin sheet. So basically, it's a disc. It's a half disc, and on the plane surface of the half disc, a parallel beam strikes at an angle of incidence of 45 degree, and the refractive index of the material is given to be root 2. This also means that the critical angle for this material and air would be 45 degree. Okay, because if I go by this, like sine of critical angle is equals to mu rarer upon mu denser. So I get this. So critical angle will be 45 degree. We can see it from here. So first thing that what we are going to do, let's notice few facts here. So all these rays, this one, this one, this one, this one, this one, all these rays strike this plane interface at the same angle of incidence, which is 45 degree. They all enter into the same medium, and therefore the angle of refraction for all these rays should be same. So all these angles should be same, which also means that this incident parallel beam, when it becomes the refracted beam, it still moves as a parallel beam. Okay, so let's do some calculations here. So I will make the half disc. I am deliberately making a large figure so that we are able to draw things clearly, and I'm making the figure by using my free hand, so therefore you don't see that clarity. Anyways, so rays coming like this. So let me first pay attention to the ray which is going through the center. So I'll apply Snell's law. So I will write sine 45 degree by sine r is equals to root 2. On solving this, we are going to get sine r equal to 30 degree. You can do that by yourself. So this ray deviates towards the normal, so this angle becomes 30 degree. All right, and since it is going from the center at this interface, at the curved interface, this ray is going to go undeviated. Okay, now as far as the other rays are concerned, the other rays will travel parallel to this till the interface, till they encounter the other interface. Okay, so they are going to travel like this. Okay, so all these rays are making the same angle 30 degree with the normal, with this normal. Okay, now the first thing to notice here is that there will be a region where the refracted ray will not strike, like this ray, the last ray will become a chord. This will become a chord such that if we join this with center, let me draw it in a light color, let me use this color. So if I join this with center and here, so this becomes a chord. This angle will be 60 degree, and it will be 60 degree for all the rays, not only for this one, it will be 60 degree for all the rays. So this is 60, this is 60, so even this will become 60. So the refracted rays are going to strike this region, so this is the region of this semicircular disc where refracted rays are going to strike. Okay, and the value of theta, this angle is 60 degree. So from theta equal to 60 degree, refracted rays begin. That means for this particular value of theta, we see the refracted rays striking the second interface. Now for this particular ray, the extreme one, if I ask you the angle of incidence, you will probably say 60 degree. You should say that, which means that the angle of incidence is greater than the critical angle. Critical angle was 45 degree. So this ray is bound to suffer TIR. So from here it will go in this direction. It is going to suffer TIR. So this ray is definitely suffering TIR. Okay. As far as this ray is concerned, the middle one, the one that passes through the center, this is definitely not suffering TIR. So as we move from this position to this position, we see that TIR was happening and later it was not happening. Okay, so it must have stopped, or there must be some position where the angle of incidence will become equal to the critical angle, and after that TIR will stop happening. So let's say the position is this, like this is the position where TIR stops. Okay, TIR was taking place in this region. Okay, TIR was happening in this region, and this is the boundary where TIR stops. So basically I am suggesting that this angle should be 45 degree. This is the first ray which will fail to suffer TIR. That means it will go out grazing the interface of the medium and air. So if this angle is 45 degree, okay, we know that this angle for all rays is 60 degree. Then the third angle of this triangle, this angle I'm talking about, this angle will become 75 degree, and this angle is what we are calling as theta. So yes, from theta equal to 75 degree, TIR stops. Now will it stop for the entire remaining range? Let's see that. So again, the ray which is striking the above extreme, for that ray the angle of incidence is very, very close to 90. Think about this. This ray will strike a point like this. So here this angle we are talking about. So you can say that we are talking about a very short chord here. Okay. So the angle of incidence is pretty large here. So this will suffer TIR. So again, there will be a region where TIR is happening. Okay, and it will stop somewhere. So let's say this is the position where TIR will stop. So a ray will probably travel like this, then it will travel like this, such that this angle is 30 degree, and it will strike here at 45 degree. So if this is 45, this is 30, then this angle is 90. So this angle becomes how much? So this is 120 plus 45, 165. so this becomes 15 degree. So when we measure like this, this angle becomes equal to 165 degrees. So theta is equals to 165 degrees for this position. So you can say that this region, okay, this region, in this region TIR is not taking place, and this is, I think this is quarter part of a circle, because yeah, this angle, the difference of the two theta is 90 degrees, so this is quarter part of a circle. So this is the region where TIR is not taking place. So by our discussion that we have had up till now, let's check what options we can select. So light rays come out of the curved surface for value of theta in this range, so that this is correct. Range of angle theta is independent of the angle of incidence. Let's just check this by considering some simple cases. For example, if we would have been given a situation in which the angle of incidence was 0 instead of 45, then the rays would have come like this. Now this is a symmetric figure, so whatever would have happened here would have happened symmetrically. That means we would have got symmetrical values of theta. Alright, right now it doesn't look symmetrical to me. This angle is 15 degree, whereas this angle is 75 degree. So in this case, if at all, whatever is going to happen, it is going to happen symmetrically. Here I don't see that. That means the angle of incidence is certainly affecting the range. So it says it's independent of the angle of incidence. This is wrong. The range theta depends on the refractive index. Again, this looks quite obvious, because let's consider a case in which we make the refractive index very close to 1. Let's say something close to 1.0001. So that will drastically increase the critical angle, and it becomes less and less probable that TIR will ever take place. So if we change the value of mu, we can modify the chances of TIR taking place, and that will also lead to a change in the range of theta. So this is correct. It depends on the refractive index. Now option D is a great one. It says all the emergent ray cross the line OP, which is refracted at an angle of theta equal to 120 degree. Now pay attention guys, this special ray, the one that passes through center, for this ray, this angle is 30 degree, which means theta for this ray is 120 degree. So the ray that has been talked about in the option D is actually the ray which is passing through the center. This ray, this particular ray will have theta as 120 degree. Okay, now let's observe one thing. All the rays that are moving in this medium, they are parallel to this ray. Alright, they are parallel to this ray. And let's talk about the rays below this. When these rays emerge, they will deviate away from the normal. That means instead of following their usual course, they will bend upwards. Because the normal is below them. So they will bend upward, as they have to bend away from the normal. So they are going to intersect this. All the rays which are coming out from below, they were parallel to this ray initially. This ray goes undeviated, but these rays suffer an upward deviation. So yes, they are bound to cut this ray. Okay, now let's have a look at the rays which are above this ray. Let's call this as the alpha ray. Not that alpha ray, alpha particle ray, but just giving a name to this so that it becomes easier to talk. Any ray which was in this region, for this kind of rays, the normal will be above. They will deviate away from the normal, so they will suffer a downward deviation, and hence they are also going to cut this ray. So option D says that all the emergent rays, they are going to cross the line OP. So yes, this option is correct. So the correct answer for this question would be ACD. Now what's good about this question, you see we haven't done any calculation, and yet we took so much time to discuss this question. It's a total concept based question, so I really like this question. Let's move on to the next one now. So we are now looking at the next question. A certain rod of uniform cross section area A and length. So there is a rod given to us. The cross sectional area is given, the length is given. It's thermally insulated on the lateral surface. The thermal conductivity of the material varies with, so the thermal conductivity varies with temperature. The two ends of the rod are maintained at, so T1 and T2. The question doesn't say that T1 is the temperature at the left hand, but let's just assume that. So that means there would be a steady flow of heat. Like after some time, a steady flow will be obtained, and that flow will happen like this. Okay, now this also means that the different segments of this rod will have different temperature. Like the temperatures are going to be different, which also means that their conductivities are going to be different. Okay, so we have to select the option. So how do we proceed in this question? So let's say that at a distance x from one end, at a distance x, we consider an element of length dx, and the temperature here is T, and as we move ahead it becomes T plus dt, with dt being a negative quantity, because as we are moving rightwards the temperature is decreasing. From 90 it is becoming 10, so the temperature is decreasing. Now for this element there is a constant heat current flowing through it. There is a heat current flowing through this. Let's call it as I. So this I represents this heat current. So the equation that we can write here is that the temperature difference, mod of that, divided by the resistance of this segment of this element, that is equal to I. So let's try to build on this relationship. If you have understood this relationship, I think we are done here. So mod dt will become minus dt is equals to I into resistance. Resistance will be L upon Ka. L will be dx for the segment, K is alpha by T, and area will remain A. So here the relationship that we are getting is minus alpha dt by T is equals to I dx by A. Now pay attention that I is a constant here. Okay, so when we solve this equation we get minus alpha ln T, where T is from, let's say, left hand it was T1, at a general position it was T, is equals to I by A into x minus 0. So this means that ln T by T1 will be equal to minus Ix by alpha A. Okay, and this also means that uh, T by T1 will be equal to e raised to power minus Ix by alpha A. Now for x equals to L, we know that T will change to T2. So this means that T2 by T1 is equals to e raised to power minus I L by alpha A. So using these two equations, I hope we will be able to check all the options. Let's see. So the first option says that temperature at 50 centimeter from colder end. So colder end is this, colder end is this one. So 50 centimeter from here. The length of the rod is 2 meter. So 50 centimeter, that means we are talking about L by 4 from the colder end. So from the end from which we are measuring x, this becomes 3L by 4. We have to find out temperature there. Okay. So I think we'll first have to figure out the value of current. So let's first figure out the value of current. So ln 9 is equals to minus, actually it will become minus ln 9 is equals to minus IL by alpha A. So have we been given the value of alpha? The value of alpha has not been given, but we can substitute this I by alpha entirely. So it will become 2 ln 3 into the cross-sectional area by length is equals to I by alpha. Now substitute this value here. So T by T1 becomes equals to e raised to power minus x by A into minus x by A into I by alpha. I by alpha becomes 2 ln 3 into A by L. A gets cancelled. So we get e raised to power, ln 3 into 2x with a negative sign by L. This is what we get. So this can be written as e raised to power ln 3 can be written as 3 and then minus 2x by L. So it becomes like t by t1, it becomes equals to 1 upon 9 raised to power x by L. Yes. Now if we substitute to check option A, we have to substitute x as 3L by 4, right, 3L by 4. Okay, so this will become 1 upon 9 into 3 by 4. So t will become 1 upon root 3. This will become 3 square, actually 3 root 3 into t1. T1 was 90 degree, so it becomes 30 divided by root 3, or you can say it becomes 10 root 3, which is like 17.3 degrees Celsius. So option A talks about that. Option A is correct. Now temperature at 50 degree from the hotter end. So 50 degree from the hotter end. So for this option we'll put x equals to L by 4. Okay, let's try that also. So from here t will become t1 into 1 upon 9 into 1 upon 4. X is L by 4. So this becomes 90 degree upon 3 square. So this becomes 3 root 3. So this becomes 30 into root 3. Okay, so that is 3 times of the previous value. So that is close to 51.96. So yeah, even this is correct. Option B also seems to be the correct one. Now rate of heat flow per unit area cross section. So we are talking about rate of heat flow per unit. I by A we are talking about. Okay, so here we obtained the value of I by alpha. So we can rearrange these terms to get the value. So we obtained that 2 ln 3 by L. L is 2 meter by L into alpha is equals to I by A. So this becomes what? This becomes ln 3 into alpha. Now ln 3 is close to 1.1, so this option is also correct. Okay, now temperature gradient is numerically higher near the hot end as compared to the cold end. So temperature gradient we can check from here, like this part of the equation we can check. Like temperature gradient would mean dt by dx. So we can see that I is constant, A is constant, alpha is constant, but dt by dx will be proportional to T. So yes, dt by dx will be higher where temperature is more or temperature is higher. So temperature gradient is numerically higher near the hot end as compared to near the cold end. So D option is also correct. So all 4 options are correct in this question. Let's have a look at question number 30 now. So it says that positronium is a short-lived mound of electron and positron. So basically in positronium atom what happens, a proton and an electron, they revolve around their common center of mass, which will be midway between these particles because these are particles of equal mass. So if mass of this particle is m and mass of this particle is m, then in such cases what we can do, by writing the Bohr's quantization condition and deriving the expression that we derive for Bohr model, we will get similar expression with only one difference, and the difference would be that m will be replaced by reduced mass. Okay, so the energy expression in Bohr model is 2 pi square minus sign minus 2 pi square k square z square e raised to power 4 m by n square h square. So instead of this m, we will have the reduced mass, which in this case is m by 2, where m is mass of electron. So for this new atom, or for positronium atom, this value will be applicable, like m by 2 by n square h square, which means if we divide E prime by E, then we get half. E prime by E we get half, which means E prime will be E by 2. Okay, so A option will be correct here. Similarly, if we write the expression for radius, the expression for radius is n square h square by 4 pi square k z e square m. N square h square by 4 pi square k z e square, so there would be a z also, into m. So for the positronium atom, we will have everything same, like n square h square by 4 pi square k z e square m by 2 we will have. That means when we divide r dash by r, we get 2. So the radius will be twice of what we get in Bohr model. So here radius is being represented by a naught, so this will be correct. Okay, and then v represents what? Speed of the electron. So for the expression for speed is uh, uh, nh by 2 pi, I'm sorry, this is 2 pi k z e square by nh. That's the expression for speed. So it is independent of mass. So in this case it will remain same. So that means there is no more option to be selected, because though this part is correct, but because this is wrong, therefore we'll have to discard option D and option B. So only A and C will be correct here. So we are now looking at question number 31. Again a question from optics, and again it's a very time consuming one because we'll have to check all the 4 options. So it says that we have a double convex lens. We have a double convex lens with different radii of curvature. One is 20 centimeter, the other one is 60 centimeter. Okay, it's made up of a transparent material of refractive index which is 1.5. So we have to choose the correct option. So the first option says focal length in air. So that is pretty simple at least. So focal length in air will be calculated by using lens maker's formula. So it will be 1.5 minus 1 and then 1 upon 20 minus 1 upon minus 60. So it is going to be 0.5 into 60 can be taken as LCM. So it will become 3 plus 1, so 4. So 1 upon 15. So yeah, on solving we are getting F as 30 centimeter. So this statement is correct. Now lens behave as a concave mirror of focal length 10 centimeter when silvered on the surface of radius 60. So let's check B option. So if I draw the lens, then this is having a larger radius of, let's say, 60 centimeter. This will have 20 centimeter. If we silver it on this side, then equivalent focal length can be obtained as 1 upon focal length of mirror minus 2 times the focal 1 upon focal length of lens. So the system is going to behave as an equivalent mirror. So for this concave mirror, the focal length will be minus 30, and then the focal length of lens was 30 degree. We calculated it already. So 1 upon 30 into 2. So we get this as 30 can be taken as LCM, minus can be taken out as common quantity. So 2 plus 1 becomes 3. So the equivalent focal length is coming out to be minus 10 centimeters. So yes, it will behave as a mirror and as a concave mirror. So this is concave mirror of focal length 10 centimeters. So even this is correct. Now option C says that lens behaves as a concave lens if the image space beyond 60 centimeter radius is filled with transparent liquid of refractive index this much. Okay, so let's see now. So now in option C, we want to check what happens if we fill this space with another medium of refractive index 5 by 3. So let's say this is 5 by 3. This was 1.5 only, and this is air only. This surface has a radius of curvature of 20. This has a radius of curvature of 60. So we want to know the equivalent, whether this combination behaves as a converging lens or not. Now to check that, let's just assume that what happens if a parallel beam is coming. Like I'm going to assume the same arrangement, but I'm going to assume that a parallel beam is coming from this side, and if this beam diverges, then we are going to call this combination as a diverging combination. If this beam converges, we are going to call it as a converging combination. Also, Let's assume a thin layer of air here. Remember, we can assume a thin layer of any medium anywhere if we are dealing with paraxial rays. So this is the region. This is the region. I'm shading it with this mesh. So this is the region where refractive index is. I think it was 5 by 3. Yes, 5 by 3. So these rays will first travel and they will move through the lens, and they will tend to move towards the focus of this lens, and we calculated the focal length of this lens to be 30 centimeters. So these rays are heading towards a point which is at a distance of 30 centimeter. So I will now apply the equation of refraction at curved surface for this surface. So I'm going to use mu 2 by v minus mu 1 by u is equals to mu 2 minus mu 1 by r. Mu 2 will be 5 by 3. V will be something that we want to find out. V is what we want to find out. Mu 1 will be air. U will be plus 30 is equals to 5 by 3 minus 1 upon radius. It will be minus 60. So this becomes 5 by 3v is equals to, so this becomes 2 by 3. 2 by 3, so 2 by 3 divided by minus 60, and this becomes plus 1 upon 30. So we can take 180 as the LCM here, or this 2 will cancel, it will become 30, 90. Let's take, okay, let's do it in two steps. In an attempt to do it in one step, there may be some calculation mistake, so let's just simply do it. So we will have minus 31 upon 90 plus 1 upon 30. So taking 90 as the LCM, minus 1 plus 3, minus 1 plus 3, so it becomes 2 by 90, so 1 upon 45. So V comes out to be a positive number. It comes out to be 5 into 45 by 3. So it comes out to be 75 centimeters. So these rays will head towards a point here. So for a parallel beam, this entire combination is actually behaving as a converging system. So this says it behaves as a concave lens. That means a diverging lens. So this is wrong. This is wrong. Okay. Now we will check D option. A beam of rays incident parallel to principal axis focuses at 48 centimeter behind the lens if this refractive index fills the entire space behind. Okay, so similar option, but this time we are considering here a 4 by 3 instead of a 5 by 3. Everything else is same, I guess. Okay, so our method will remain same. I will just change these numbers. So I will now write 4 by 3 by V minus 1 upon 30 is equals to 4 by 3 minus 1 will become 1 by 3 upon minus 60. So 4 by 3 by V is equals to 1 upon 30 minus 1 upon 180. So 180 becomes the LCM. 6 minus 1 becomes 5. So V will become 4 by 3 into 180 by 5. 4 by 3 into 1, yeah. So this becomes what? So this becomes 60 and 12 and 48 is what we are getting. So focus is, yeah, so D option is correct. So for this question, A, B and D are the correct answer. So this is the last question of part 1. Let's have a look at this. A thick hollow cylinder of height h, inner radius A and outer radius B, made up of poorly conducting material. So we are talking about a cylinder like this, cylinder such as this. Okay, so this cylinder is placed inside a solenoid. So it is placed inside a solenoid, and that solenoid is producing a magnetic field. It's uniform, but it is varying with time. So it's producing a magnetic field like this. So if we look from the top, if we draw the top view, okay, so we will be looking at the inner radius of the cylinder, at the outer radius of the cylinder, So this radius will be let's say A, this radius will be B, and there will be magnetic field present in this region which is changing with passage of time. Magnetic field is becoming stronger. So if the magnetic field is becoming stronger, it will induce an electric field in the surrounding. So for starters, we can tell that there will be electric field lines like this. Okay, so these electric field lines will cause current in the cylinder, and the current will move along the path of the electric field line, just as I'm drawing the electric field line. So current will flow in a similar manner. Let's now read the options. So EMF induced at a certain radius in the hollow cylinder. So how we can say that? So EMF induced in a certain radius. So if we are talking about a distance r, here we are talking about EMF induced. So we can apply Faraday's law. So EMF induced will be equal to rate of change of flux. So pi r square into magnetic field will become flux. Rate of change of this, so it will be like pi r square into dB by dt, and B is given to be as beta times of the, so derivative will become beta. So it says that pi r square beta, so A option is correct. Now induced current circulating in the thick hollow cylindrical. So guys, for here what we have to understand that there will be different currents flowing like this, and we have to sum these current. Okay, like if we consider an element of radius x and width dx, then some current will be flowing through this element. So we have to write that current, and we have to add all such currents. Okay, so if I consider an element of radius x and width dx like this, so the resistance of this element will be written as resistivity into the length. Length is considered to be the length along the direction of current flow, so that will become 2 pi x upon area of cross section. So area of cross section will be the height into dx. Okay, so the current flowing through this element will be given by EMF divided by dr. So it will become pi x square beta. I'm using this relationship from here. At a distance x, the EMF will be this much. So pi x square beta is EMF divided by dr will become h dx upon rho 2 pi x. Now we have to integrate this current to get the result. So let's first cancel out the common quantities. So 1x will be gone, pi will be gone. So we will be left with beta into h by 2 pi. So we have taken care of this rho and 2. So dx, so we'll integrate this x dx, and the limits will change from b to a. So we'll get b square minus a square by 2. So bh upon 4 rho, bh upon 4 rho, b square minus a square. So this option is also correct. Now the resistance offered to the circulation of the current. Now this can be obtained by using this expression. So these resistances, like these shells, they can be assumed to be connected parallelly with each other. So using this expression we can find out the equivalent resistance. So 1 upon r equivalent is integration of 1 upon dr. So we'll get integration of h dx upon 2 pi rho x. So h by 2 pi rho will be taken out as the common quantity, and we'll get ln b by a. So the resistance will be 2 pi rho by h ln b by a. Let's check the option. So 2 pi rho and then h ln b by a. So even C option is correct. Now D option says no electric field is detectable outside the solenoid. Well, that's not correct, because because the magnetic field within the solenoid is changing, that will cause electric field to be induced outside the solenoid also. That's part of theory that you should know to answer this question. So D option says no electric field will be detected, so D option is incorrect. So the correct answers are A, B and C. So that finishes our discussion of paper 1 of IOQP. The questions were really good, and if I tell you about the MI score, so the MI score is going to be around 75 to 80, and the MAS will be around 47 to 50 based on this paper. All the best, students, all the best, and I hope you all get selected. Take care. I'll bid goodbye for now. Bye, guys.